This conversation is powered by Google Illuminate. Check out illuminate.google.com for more. Welcome to the discussion. Today, we're diving into the fascinating world of interactive physics simulations, specifically focusing on a tool called the Kinematics Car Y Direction Simulator. It's designed to help students grasp complex kinematic concepts.
Indeed. This simulator offers a unique approach to teaching kinematics, moving beyond static textbook examples.
It seems to emphasize graphical analysis. How crucial is that aspect in understanding kinematics?
Absolutely crucial. Visualizing displacement time and velocity time graphs is key to understanding the relationships between position, velocity, and acceleration.
And what about the role of air resistance? Does the simulator address that?
Yes, it allows students to explore free-fall scenarios with varying levels of air resistance, illustrating the concept of terminal velocity.
Let's start with the core of the simulator, the interactive kinematic simulation itself. Can you elaborate on its functionality?
The simulator uses a virtual car to represent an object in motion. Students can manipulate the car's initial velocity and acceleration, observing the resulting motion in real time. They can explore scenarios ranging from a car at rest to uniform and non-uniform motion, including constant and changing acceleration.
So it's not just about observing motion, it's about actively manipulating variables and seeing the consequences.
Precisely. This active learning approach is far more effective than passive observation. Students aren't just told about the concepts, they experience them directly.
The simulator heavily emphasizes graphical analysis. How does it help students interpret displacement time and velocity time graphs?
The simulator simultaneously displays the car's motion and the corresponding graphs. Students can directly see how the shape of the graph reflects the type of motion, whether the object is at rest, moving with uniform velocity, or undergoing uniform or non-uniform acceleration. This visual connection is incredibly powerful.
And the freefall component with air resistance, how does that enhance the learning experience?
The ability to model freefall with and without air resistance is a significant advantage. Students can observe how air resistance affects the object's velocity and acceleration, leading to the concept of terminal velocity, a constant velocity reached when the forces are balanced.
The simulator encourages the use of mathematical models. How does this integration of theory and practice benefit students?
The simulator provides a visual representation of the mathematical models. For instance, students can see how the equation for uniform velocity, y equals y0 plus ut, translates into the graph and the car's motion. This reinforces the connection between the abstract mathematical concepts and the real-world phenomena.
And what are the key learning goals the simulator aims to achieve?
The primary goals are to develop a strong understanding of displacement, velocity, acceleration, and their graphical representations. Students should be able to interpret graphs, predict motion, and understand the effects of air resistance and gravity.
The simulator boasts several interactive features. And what are some of the most impactful ones?
Beyond manipulating velocity and acceleration, students can switch between different views, world view, position view, velocity view, and acceleration view, to gain a comprehensive understanding of the motion from various perspectives. This flexibility is key.
And what about accessibility? Is it easily accessible to students?
Absolutely. It's implemented as a JavaScript applet, HTML5, making it readily accessible through web browsers on various devices. It's also embeddable in web pages, making it easily integrated into online learning platforms.
Let's highlight some key facts. What's the default acceleration setting and why is it significant?
The default acceleration is negative 9.81 meters/SOs, approximating Earth's gravitational acceleration. This allows for realistic simulations of free fall.
And can you share a particularly insightful quote from the documentation that summarizes the simulator's capabilities?
The description highlights the simulator's ability to provide the experience and evidence for describing the motion of bodies with constant weight falling with large and small, or without air resistance, including reference to terminal velocity. This perfectly encapsulates its core functionality.
The accompanying study guide includes a quiz. What kind of questions does it pose to assess student understanding?
The quiz tests comprehension of key concepts like speed versus velocity, interpretation of graphs, and the value of gravitational acceleration. It also probes understanding of terminal velocity and the effects of air resistance.
And how effective is this quiz in reinforcing the concepts learned through the simulation?
The quiz is designed to be a direct application of the concepts explored in the simulation. By answering the questions, students solidify their understanding and identify any areas needing further review.
The study guide also includes essay questions. What kind of deeper thinking do these questions encourage?
The essay questions require students to synthesize their knowledge and apply it to more complex scenarios. They encourage critical thinking and problem-solving skills, going beyond simple recall.
And the glossary of key terms, how does that contribute to the overall learning experience?
The glossary provides a concise and readily accessible reference for all the important kinematic terms, ensuring students have a clear understanding of the terminology used throughout the simulation and study guide.
The instructions for using the simulator are straightforward. What are the key steps involved in adjusting parameters and interpreting results?
Students can adjust acceleration and velocity using sliders or by dragging elements within the simulation. They can then observe the changes in the car's motion and the corresponding graphs. The combo box allows selection of different views for a comprehensive understanding.
Are there any further research opportunities or extensions that could be built upon this simulator?
Absolutely. The simulator could be expanded to include more complex scenarios, such as projectile motion in 2 dimensions or the effects of different types of forces. Further research could also focus on the effectiveness of this type of interactive learning compared to traditional methods.
The documentation mentions video tutorials. How valuable are these supplementary resources?
Video tutorials can provide a visual demonstration of how to use the simulator and interpret the results. They can also offer additional explanations and examples, making the learning process more engaging and accessible.
Are there any other resources or materials that complement the simulator?
The documentation links to blog posts that provide further details and examples. These supplementary resources offer additional context and support for students and educators.
The FAQ section addresses common questions. What are some of the most frequently asked questions about the simulator?
Many questions focus on how to explore different types of motion, interpret graphs, and understand the free-fall scenarios with air resistance. Others relate to adjusting parameters and accessing additional resources.
How effectively does the FAQ section address these common concerns and provide clear answers?
The FAQ section provides concise and informative answers to common questions, ensuring users can quickly find the information they need to effectively use the simulator.
The webpage shows statistics on online users. What does this data tell us about the simulator's reach and popularity?
The statistics indicate the number of concurrent users and the total number of article views. This data provides insights into the simulator's usage and its impact on the online learning community.
And what about the use of tags to categorize the simulator's content?
Tags like dynamics, electricity and magnetism, and educational levels, primary, secondary, junior college, help users quickly find relevant content and understand the simulator's applicability across different educational contexts.
That was a great discussion. Thank you for sharing your expertise on the Kinematics Car Y direction simulator and its potential for enhancing physics education.